Hello guys, welcome to my channel Psychology Point. Today we are talking about that why your brain won't let you forget the bad stuff. So let's start. The nature of depressive rumination. Depressive rumination is a specific, perseverative cognitive process. The repetitive, negative, self-referential thought. There is a sharp distinction between experiencing a negative emotion, like sadness or grief after a discrete event, and ruminating on a negative self-concept.
One is a
reaction.
The other is a prolonged internal evaluation of perceived flaws.
In adolescent depression, negative cognitive schemas function as actively maintained structures rather than passive byproducts of a low mood. The mechanics of the rumination filter. This schematic of an information processing stream demonstrates how rumination acts as a gatekeeper. As the rumination variable increases, the filter actively traps incoming negative data while discarding positive data before it can be encoded. Adolescent depression is sustained by this self-reinforcing mechanical loop.
High-trait rumination physically alters how memory is encoded, forcing the brain to gather evidence that confirms its own negative bias.
Relying purely on observational clinical psychology limits our understanding of exactly how this filter operates. Observing a patient's behavior only captures the final output of a complex internal system. Measuring the brain's hardware
to bridge the gap between abstract self-referential thoughts and physical brain mechanics,
we require multimodal research that examines the hardware directly. Measuring this loop requires a two-pronged approach. We must test how the brain physically reacts to a negative stimulus in the fraction of a second it appears, and then verify what that same brain objectively remembers hours later. We synthesize these two domains by combining behavioral memory testing with functional magnetic resonance imaging, or fMRI.
Mapping the precise neurobiological substrate of this filter provides the data necessary to transition clinical treatment from symptom management toward structural intervention.
The Self-Referent Encoding Task, SRET. The gold standard for measuring these cognitive schemas in real time is the Self-Referent Encoding Task, or SRET. This timeline traces a single SRET trial. A valost word appears briefly, and the subject indicates if it describes them. After a critical 15-minute delay, the subject completes an objective recognition test. Separating immediate endorsement from delayed recall ensures we measure actual memory retention. In healthy subjects, the baseline recall data shows a standard positive encoding bias.
They remember far more of the positive words they viewed than the negative ones.
When we test adolescents who score high for trait rumination, the behavioral data shifts in the opposite direction. This chart isolates D' recognition accuracy. As trait rumination increases, the trend lines diverge. Positive word recognition drops, while negative word accuracy spikes significantly. This divergence indicates a structural encoding bias, proving subjects capture and store more negative data at the hardware level.
The
SRET data indicates that high ruminators operate with memory hardware actively biased to retain negative, self-referential information while discarding positive evidence. To identify the mechanism causing this memory bias, we examined the instantaneous neurological event captured via fMRI at the exact moment subjects viewed the words.
We are focusing on the
salience network, which toggles the brain's focus between externally oriented attention and internally oriented self-referential processing. High rumination adolescents show anomalous activity in two network nodes, the anterior insula and dorsal anterior cingulate cortex. During the evaluation of negative words, these regions exhibit hyperreactivity. This functions as an exaggerated tagging mechanism, artificially elevating the negative stimulus's personal importance.
We also observe secondary involvement from the lingual gyrus, which supports the visual encoding pathway for these stimuli.
This instant hyperreactivity in the anterior insula and dACC directly correlates to the delayed spike in the SRET D' score. The intensity of the initial network reactivity predicts how accurately the subject will recognize the word 15 minutes later. The salience network hyperresponds to negative self-referential cues, prioritizing their encoding into long-term memory, while neutral or positive data points are discarded. Clarifying clinical measurements. This neural mechanism clarifies a critical conflict in how we actually measure rumination in patients. The Children's Response Styles Questionnaire, or CRSQ, provides a retrospective self-report of global long-term trait rumination. Ecological Momentary Assessment, or EMA, provides a real-time measure that captures recent stress through daily smartphone surveys. Research often assumes that these two methods map to the same underlying neural activity. Comparing predictive validity reveals a divergence. Both trait and state rumination predict behavioral memory bias, but only the CRSQ, the global trait measure, correlates to anterior insula hyperactivation. Momentary stress captured by EMA cannot predict this specific neural hyperreactivity. The neural signature of a depressive memory bias is driven by a global self-concept rather than a transient bad mood or recent stress. The hyperreactive salience network is a structural trait of depression, which identifies it as a target for long-term intervention rather than acute crisis management. The neurocognitive loop and clinical treatment, synthesizing the fMRI data with the delayed SRET behavioral data, allows us to construct a unified timeline of how the ruminative brain processes a negative event. High trait rumination establishes a baseline. When a negative cue appears, the salience network overreacts, elevating memory encoding. The brain retains this negative data, reinforcing the negative self-schema and raising the baseline. The network is now primed to react even more aggressively next time. Depressive rumination operates as a closed, self-sustaining mechanical loop of pathological information processing. This neurocognitive loop dictates the clinical requirements for treating adolescent depression. Interventions focusing only on lifting mood often fail to counter a structural encoding bias. The brain's hardware continues to actively filter for the negative. Effective treatment necessitates downregulating the reactivity of the salience network to external negative cues. Targeted interventions, such as specific mindfulness protocols or positive emotion refocusing techniques, serve as mechanical tools to interrupt the tagging process in the anterior insula before the memory is encoded. By mapping the exact neurobiology of rumination, clinical psychiatry can shift from managing sadness to systematically repairing the brain's information filter. Now tell me, have you ever caught yourself replaying a negative thought over and over, even when you try to stop? Drop a comment below and tell us, what's one negative thought that keeps coming back to you? And have you found anything that helps quiet it? Okay guys, take care and don't forget to like, share, and subscribe my channel. Thank you.